of like some people tried, some people didn't, some people got it, some people didn't. But on the first two, you know, it was sort of like normal types of problems. Okay, let's look at this one. If I say, what does 1 over I equal, you want to simplify it, right?
So you have to get the I to the top?
Yes.
So
how would you get the I to the top?
1 out of the negative.
Multiply by what? Say it.
I was already as an I to the negative 1, but multiply it by I.
Okay. Well, if I multiply the denominator by I, and in fact, if we did it like we used to do it with the complex conjugate, let's multiply by negative I, okay? If I multiply the denominator by negative I, what do I have to multiply the numerator by? Negative I. So what do I have in the numerator? And what do I have in the denominator?
Negative I squared.
Okay, negative I squared. I squared is equal to what?
Negative 1.
Negative 1. And negative 1, what goes on the bottom?
1.
1. So 1 over I is equal to negative I. Okay, and that's actually an identity, and it's something in imaginary numbers you need to know, but it's kind of odd, isn't it? I mean, 1 over I is negative I. It's kind of odd. So really, you guys could have done this, right? Because, I mean, you told me, what do? You multiply by negative I, the complex conjugate, and then negative I, and then the whole thing works out. So that's a freebie. And I want to start doing that on bonuses. I want to kind of just throw in whatever I want to. I mean, just something that you should know, even if it wasn't something that we worked in the last 6 weeks or the last few weeks. So nobody got that one. That's okay. Grades were good. It was a great opportunity to get 10 free points. Okay. Where are we? We in chapter 7?
7-1.
Yeah, 7-1.
Oh.
All right. Victor asked me, yes.
We have a question on 23.
Okay, what does it ask?
Write the complex number shown below in trigonometric form. It gives you a graph and the vector.
You did what? Okay, let me look at that and do it tomorrow. Okay, because I need to go on with this lesson, and then I will answer it. But just I'd rather work it out than try to figure it out in real time. Okay, so we will do this, and then I will look at that. It seemed like a lot of people missed that one. Okay, Victor asked me about this week. Friday is a short day, and isn't it cheerleader thing on Friday? Okay, so let's do test on Thursday. And we have to have a test because remember we missed the first week, and so we don't want to miss another one. So Thursday will be the test.
Make sure you tell
It's
Okay.
We're recording.
Okay.
I wasn't sure.
So test on Thursday. All right. And you're going to be gone for how long, or when are you?
Wednesday, Thursday, and Friday.
You're gone Wednesday, Thursday, and Friday. So that is going to create a challenge. Can you take it Monday?
After spring break.
Monday after spring break, before school.
Sounds good.
Okay. And so
Yeah, I mean, I can take it tomorrow if you want me to study up.
no, because I haven't had the lesson yet. So
Right.
I mean, you can't take it tomorrow.
Okay.
And it does not create an inconvenience for you to take it on Monday. It's just you have
hard
the
to study.
situation that you're going to be gone for a long, long time. So then that's something you have to be cognizant of, that don't just come on Sunday night and open the book, right? I mean,
Right.
you've got to kind of be thinking about this over spring break. Okay. So we have all of this figured out. And we are chapter 7, section 1. Okay. So this, we're going to go back and talk about systems of equations. We've done systems of equations before, and we sort of called it like 2 equations and 2 unknowns. Okay. And so I have x plus y equal 4, x minus y is equal to 2. There's 2 different ways to solve that. Noah, what's one way?
X when you substitute.
It's called substitution. Will, what's the other way?
Eliminate.
Oh, where you?
Elimination, right? Like, were you going to say it like where you add the two together? Okay, so you were thinking it and you said it. Okay, you add those two together, y goes away, I've got x. Day in and day out, if you just had one way to do it, how would you do it? Substitution, right? I don't like elimination. I mean, it works, but I don't like it very much. And there's one other way. Victor, what's one other way that you can do it besides substitution and elimination?
Is there a sublimation or?
Sublimation, no, there is no such thing as sublimation.
There isn't one.
Sublimation is where a liquid goes from a solid to a gas
There we go.
in one second. It's the critical
It's kinda
point.
like-
Yeah, you can plot it.
Yeah, we're doing like kind of.
Yeah, you
Well,
can.
can I just combine the two words?
So if you want to do sublimation, you need to go in and talk to Ms. Parker. There's not going to be any sublimation going on in here. Okay. Well, what did you say?
Plotting them.
Graphing.
Graphing them.
Right.
Oh.
So if you graph it, it's like this and it's like that. That's your solution. Okay, 3 different ways to do it. Day in and day out, I like to do substitution. So I would have x is equal to y plus 2. I just rearrange that. Now, what do I do with this x? I put it in there. Because I rearranged this one, I put it in the other one, and I have y plus 2 plus y equal 4. I have 2y is equal to 4. 2y is equal to 2, y is equal to 1, yeah? And then you plug the 1 into here, and you say 1 plus something is equal to 4, well then x is equal to 3. Okay, I mean this, I'm just, right, this is all familiar? Everybody good with this? Franklin, you good with that? Okay. But the thing that we always did was the 2 equations and 2 unknowns were always linear equations, okay? And what you find is that's a good way to teach, that's a good way to teach substitution and solving systems of equations because it's something you can do as a sophomore in high school. But in the real life, you don't end up with lines and they don't, intersect nicely like that. And so you might have something a lot more complicated. So let's say that you had 2x minus y is equal to 1. Okay, is that one still linear?
Yes.
Yeah, that's linear, okay. But the other one might be, let's say, 3x squared plus 4x minus y equals 7. Is that one linear?
No.
No, that one is not linear, okay. And so in that case, on that,
Since one
of the 3 ways that we could solve it that we know of, what 2 would work on this? Substitution or what? Graphing. Right, I mean, you could do it with graphing. You might end up with, right, you could still use graphing. If you graph the 2 things, the solution is still what? Where they intersect. So you can always do it by graphing. But really, graphing is kind of not the way you usually want to work things. So probably we would want to do it by what? Substitution. So what do we want to solve for here?
The y.
Y. I think I want to solve for y. So y is equal to what? 2x minus 1.
Negative 2x.
Did I do that wrong?
No, that's right.
Oh,
You're right.
oh yeah, you're right. You're right. My bad.
Y comes over here, and then 2x minus 1. I think this is right. Y is equal to 2x minus 1. If I wrote this right to begin with.
Yes, you did.
Okay.
No, because of the negative on the y comes back around.
Okay, so I have.
Yeah.
Oh, I'm sorry. Right, I wrote the problem down wrong. Let me fix this. This was minus 1. So correct that. 2x minus y equal minus 1. And then what I have is y is over here is equal to 2x plus 1. Okay, we're all together on this? All right. Now, what do I do with this?
Plug it in for y.
Into which one?
Both of them.
The other one,
Oh, yeah.
right? The other one. So I have 3x squared plus what? 4 times,
2x plus 1.
right?
Parentheses.
Parentheses, okay? And then,
Minus 2 parentheses 2x plus 1.
okay. So now we got to work things out. So I have 3x squared plus what?
8x plus 4
8x plus 4
minus
minus
2x.
2x minus 1. So I have 3x squared, and then that becomes what?
6x.
Don't forget it equals 7.
Ooh. Boom.
Hey,
No. We were fixing to have a disaster here. 3x squared plus 6x, and then what? Plus 3, right?
Yeah.
Am I wrong?
no. That's 3.
Yeah, plus 3. Oh, I
Equals
slide a middle one,
And that's equal to 7. Let me make sure that I'm getting this. 3x squared plus 4x. Okay. So then what do I do?
Check the 7.
3x squared plus 6x, and then what?
Minus 4.
Minus 4 equals 0. Now, how do we do this?
Quadratic equation.
Yeah, I don't know if I can figure out 3. I would just go negative b plus or minus the square root of b squared minus 4ac over 2a. Now, I don't want to go through that, so you guys know how to do that, right? How many solutions are we going to have?
2.
2. So how could we have 2 solutions instead of 1 solution? Someone tell me, explain how this.
It crosses
It's
the
Parabola. It's got 2.
quadratic or parabola, so it's like that.
It's a parabola in a line, right? And so you're going to have 2 solutions. See how intuitively what you
Well,
would think
would you
of.
have to test both of them before? 2?
Yeah.
Because there's always that chance, because the quadratic can give you 2 solutions, but then one of them could not be correct, right?
Yeah, or what about this? There could just be what?
double root.
Yeah.
There could be, and this isn't a root, this is a solution. There could be 1 solution. Or think about this. What if I had this and I had that?
No solution.
There could be no solution.
So you.
Or how about this? I could come up and I could go like that, and there'd be 1 solution.
Yeah.
Could there be more than 2 solutions?
No.
Not.
No. There could not for a quadratic in a line. 0, 1, or 2 solutions. Okay.
So would graphing it to solve it not be a whole lot easier?
No,
Graphing
because
it
the
in
problem with,
Excel would be pretty easy.
yeah, but then what if the answer was the square root of 3 over 2? Square root of 3 is what type of number?
Irrational.
Not
Irrational.
Franklin, are you crawling under the desk? Franklin, you're doing fine. You don't have to crawl under the desk. It's going to be okay. It's going to be okay, Franklin. Are you back with us? I thought maybe we scared Franklin and he was going to crawl up under the desk. Okay, the square root of 3 is what kind of number, Will?
Not radical.
It's not a normal.
Is it a rational or irrational?
Irrational.
Okay, so if the answer was the square root of 3 over 2, you can never get the exact answer by doing it by graphing, because graphing you would have to make smaller and smaller and smaller increments. So you really want to kind of solve these algebraically, and then only when it's something that you can't solve algebraically do you do it with graphing because of issues like that. Okay, so let's work one, and let's kind of go all the way through and work it all the way through. Okay. Minus x plus y equal 4, x squared plus y equal 3. Franklin, what would you do here?
On the top one, I would solve for y.
Okay, so y is equal to what?
X plus 4
And where do I put that?
into the other equation.
Yeah, so I have x squared plus what? X plus 4 equals
3.
Okay. What do I do now? Where do I put the 3?
Subtract it.
Yeah, so I put x squared plus x plus 1 equals 0. And now I have what? A equal 1, B equal 1, C equal 1. So now I have x1, x2, the solutions are equal to what, Davis? What's the quadratic equation?
Negative b plus or minus the square root of b squared minus 4ac over 2a.
Yes. Okay. No, when I put the numbers in, what do I get?
-1 minus the square root of 1 minus 4,
Over,
2.
okay. So this is -1 over 2 plus or minus
I on the square root of 3.
I on the square root of 3, right? 1 minus 4 is -3. Minus comes out as an I, so I have -1 plus or minus I on the square root of 3 over 2. So also, Will, you see you couldn't do this one graphing either. So what would that look like graphing? Well, you would have this, and then you would have this, and they don't intersect because they don't intersect in the real domain. If you could plot them in the imaginary domain, you would see that in
So
the
if you get an imaginary number, there's no solution.
There's no
No.
real solution.
there is a
real
solution.
Well, I mean, no real solution.
No real solutions, no solutions that's going to show up on a graph.
So
So-
if it asks us in the book, find the solutions.
That's the solution.
Okay.
Okay.
Is that? But that's for both x and y.
Oh no, that is X.
That is just X.
So what would we have to do? You would
Plug
have
that
to
in for x.
plug that in for X and calculate Y. So good point. So if you put this in for X, you can solve it because there's a real and imaginary part, and it would just be the part. Let's do that.
Let's solve.
And there would be two different ones, right?
Yes.
And so what do I have? I have X equal, and you better write it out separately, I think. 1/2 plus,
Minus
No, wouldn't it be
Was
Y
that
equals
minus?
because we already
Yes.
Minus 1.
thank you, minus 1/2 plus I on the square root of 3 over 2, and X is equal to minus 1/2 minus I square root of 3 over 2. Okay, so now let's just do one of them. So this is going to go, I would put it in here because I think it would be easier. So minus what? Minus 1/2 plus I, the square root of 3 over 2. Okay, plus Y is equal to 4. So Y is equal to 4 plus, or 4 minus 1/2. On the other side, it would be minus, right?
So would it be
Mhm.
7/2?
Okay, 8/2 minus 1/2 would be 7/2. And then what? Minus I, the square root of 3 over 2. That minus, it becomes a plus. Did I go too fast on that?
Looks good.
Anybody ask me?
Yes.
So would another.
Are you good?
Yeah.
It was just easy, right? The same as the other one.
Yeah.
But it's just this one doesn't have anything, he doesn't have anybody to play with, right? So he just comes over and that becomes the I part. Okay?
So then there'd be two imaginary solutions for both X and Y.
There's what?
Two imaginary solutions for both X. and
Yes,
Y.
there's an X, but you got to see this Y goes with this X, and then the other Y goes with the other X, and so the X and Y have to go together like a point, right? Okay, this goes together like a point. Okay, Will, you said graphical approach, right? Sometimes you have to solve it by graph. Okay, so let's say I have Y is equal to ln of X, and I have X plus Y equal 1. On that, if I substitute, Y equal ln of what X is equal to minus Y plus 1 kind of thing, then I don't know how to get this thing taken apart, right? I kind of end up with something I can't do. Maybe it can be done, it's just I can't see how to do it. So on ones like that, you graph it, okay? And how do you graph it? Well, you go to Excel, and this is Y equal ln of X, like this, right? It crosses the axis at 0, it asymptotes here, and then it keeps going up like that. And then X plus Y equal 1, well, at 0, it would be 1. At 1, it would be 0, and then it would be like that. And I have how many solutions? 1. This one I can see just because it was easy. The solution is going to be 1, 0, because ln of 1 is 0, and 1 plus 0 is 1. So you can see that that one works out. But when you have something like that, you need to do it in Excel. All right. This is pre-calculus. We are going to do Chapter 7, Section 1. We're going to do 15 through 18, 30 through 32, 46 through 47, 49 through 50, and the bonus is 64. Boom.
Does he already expect you to know that?
Yeah, I guess so.
I mean, if you need to count
I feel like we are in good shape of making excellent progress in this class. I am hoping that we can kind of kick off some of the more calculus stuff this year, okay? And it would be great if we could get on a jump on calculus for next year and just at least start introducing the concepts of calculus and how you think about things and what calculus is about.
What is today?
Today is Monday.
So would you want us to put the point of it, or do you want us to put x equals y equals for the solutions?
X equal Y equal.
So at least 2 boxes if it's a linear, if there's no float.
X and Y in the same box. X equal Y equal in the same box. I think we can handle 2 in the same box.
Actually,
I know how you love separate boxes, Noah, because
I really do. I love it. And spaces out, not one.
what period is this anyway?
Fourth.
Fourth. I'm getting hungry.
Me too.
I'm ready for lunch.
About 2 weeks ago. Brain alive.
That problem on the test that a lot of us missed,
Uh-huh.
23. Are you gonna do that later or just?
Let me look at it.
Maybe.
You're welcome.
What problem was it?
23.
6, 7. 7, 9, 8, explain my choice of method.
Is it first extra value? Does it want to turn it?
Graphic, solve it graphically or application, explain your choice of method. There's gonna be at least 2 boxes. That's all you guys got to graphic.
So,
No,
But you know,
if it's a quadratic, I will solve it.
If you do it graphing, make sure that you do good graphs. Graphs need to have labels. Remember how we make a grid on the graph, so it's like graph paper, not just that goofy Excel format, right? Format it nicely and show clearly what the answer is.
It's like multiple.
And if that's not graphic, it won't give you the answer.
so, yeah.
I thought you
Probably if
were
it's
missing
quadratic,
it.
it's easier. Both of those are quadratic, so it's probably easier to do it.
I need to stop her.
We didn't stop.